Hi, MC Bling Daddy here, and welcome back to another segment in our exploration of using command blocks for coding as you might in a high-level language such as Java or C#. And today we have a couple things on our plate. One is to actually encapsulate our execution of our loop that we have used to extend the railway. That is our main objective here. We'll encapsulate it by setting up entry and exit points to do some things that we need to do before we actually execute the loop and after we have finished execution of the loop. And let's review how things are set up to do this execution. We have some preliminary things that we need to do, such as, for example, to specify which direction we want to extend our railway. We do that with an objective or a variable that we call add. In this case, since it's feeding into the loop method or subroutine that we will be looking at shortly. Add will specify how many, or which direction, I should say, we want to go with our railway. In this case, to means go or extend in the X direction. So here's one of the things that we need to specify outside of the loop is which direction are we going? Another thing that we need to specify is how many times do we want to go that way? And that's with our repeat objective, which is, in this case, 3, meaning 3 times extend 1 in the X direction, the positive X direction. Okay, so that's 3 times. Now, I hope you remember last time when we actually set something else, we are not doing that because we are moving that to our loop setup, as I'll explain in just a second, and that was to initialize the value that counted how many times we've done the loop. Well, we haven't done the loop at all yet, but we shouldn't have to specify that here because that's where we start every time, is with the loop not having been executed at all. And then the last thing we do is to transfer control, which we do with our set block of a redstone torch. And in this particular case, we are setting that torch at a place beside an entity called loop entry, which will initialize the beginning, or the setup, I should say, of our loop. So let's go take a look at that. And that is right here. And let's just verify, first of all, that our minecart with command block is actually loop entry. If you look after the first line, MC Bling Daddy is a player, but below that 1, 2, 3, 4, and the beginning of the 5th line, you'll see custom name and loop entry. Okay, so this is where we transfer control to by putting down a torch right here, which then gets removed so that it doesn't hang around and prevent further execution. And it also starts execution of a series of command blocks, the first of which is to set up our loop index. Now, loop index is how many times have we done this loop? We haven't done it at all, so it needs to be set to 0. Okay, so that's set up, if you will, for the loop. But we will be using the other parameters for the loop that we specified was 2 for the X direction and 3 for the number of times to execute. And then, once we have set up our index, then we transfer control again with, again, our standard method of transferring control by setting a redstone torch. And in this case, we are setting it beside another minecart with command block named loop. Okay, so we have then our entry point to set up how we want to start execution by indicating that we have not run the loop at all. And next, we want to see, we want to look at our exit point, which gets executed when we are all done with our loop. And so let's see if we can do this again. Okay, and again, the custom name, if you look in the same location as we did before, 4 lines down below the top one, and you'll find that the name here is loop exit. Okay, and what do we do when we exit the loop? Well, at this point, just for a simple demonstration, we'll transport me, the player, at P to the location of the minecart writable, which is the one that indicates where the railway has ended. Will transport me there, and then I can take a look back and see what has been accomplished. Okay, so that's how we get into and out of the loop method or subroutine. But in order to, in order to get in, we know where that starts, and we just execute a set block to start the execution. But to get out, we have to somehow or other determine what we're going to execute when, depending on whether we've done all the loops that we need to do. Now, you remember that the way that we decided to execute the loop content, in other words, to set blocks, set air, move the minecart, all that was done with a test for. In this case, we are in the middle of the loop, and we just check to see how many remaining loop executions there are. As long as there's at least one, we succeed, and this comparator then turns on, and as a consequence, this torch goes out. This torch will go out because of the command block that did the test for, and when both of those go out, this redstone dust will also go out, and this torch down below will go on. And that starts the execution of a series of things that end up way over here in one of these addition segments where we actually add the blocks of dirt and air and move the minecart. Okay, so, but we've seen that before. This is how we started it all out, and I hope you remember how this all works. I'm going to couch this explanation, though, a couple of different ways. One is based on logic. This is an AND circuit, but this AND circuit is based on two other kinds of circuits. One is a NOT circuit, and that means that when something goes on, like this comparator, it turns something else off. So it switches. If something's on, the output goes off. That's the same thing that happens here with our test for. When the signal comes through, the signal passes through, it changes this torch from being on to off. And as a consequence, we have another circuit here in effect, which is an OR circuit, which says if either this torch or this torch is on, then this redstone dust will be on. So when both of them go out, neither one is on, then the output of the OR circuit is off. So the torches, either one of them, either this one or that one being on, this is on. When both are out, this is off. And then again, we have another NOT circuit, which means that if the redstone is on, the torch is off. When the redstone is off, as it will be when we have a signal come through that the comparator says is something that we need to do, then the redstone will go off and the torch will go on. Okay, so those two types of circuits, not and or, are what are used. A not, or actually two nots, an or, and another not, to get our output that says, go ahead and execute the loop content, the loop statements. Okay, all is well and good. We've done this many times, but what we need is some way of deciding whether or not to simply continue executing loop statements or whether we need to stop execution. And that's what this additional torch will do. This is added in, and what will happen is that it will also go off. It's also controlled by the comparator output here. It will go off. This redstone will go off, and you'll note that we have another and based on two knots, an or, and another knot, which will feed through then to the exit, the loop exit minecart entity, command block, whatever you want to call it. Okay, so this is what's new, is this second and based on, as you see, both the comparator output, which is this side, and the test for output, which is this side. And under the right conditions, when the test for is successful, the loop will be executed. But when the test is not successful, then the conditions up here will turn on. This torch will turn on. Excuse me, will stay off. I mean, the comparator is off now, and this torch is also off. This will be off, and as our signal comes through from the test for, this will go off, and then we'll end up executing our exit point. Long-winded explanation based on logic. Now, I'm also going to couch this in terms of electrical circuits. And in this case, what one might say is that, well, without going into a great deal, without repeating some of this stuff back here, I'm going to say that basically this side with our comparator is a signal. And the signal, when this turns on, the signal will be fed through to our loop execution based on a signal coming from our comparator, which we would call or could call a gate. So when this torch goes off, it gates our signal, and if our signal from the comparator is on with these torches off, what happens is that our gate causes the signal to pass through to loop execution. When our signal, on the other hand, is off, as it is now, and these torches are on, then what will happen is the gate, rather than gating the output to the loop segments, the loop statements, it will gate output to our entity at the end, our loop exit. Okay, again, maybe a long-winded explanation, more than you wanted to hear, but let me just say that when we execute our loop, what will happen is for 3 times, actually for 4 times, our gating torch will go off. You'll see the gate signal heading up the steps here. And by the way, we had to put those steps in so that they didn't interfere with the signal that is passed on through for the loop execution. We had to get them out of the way so that they're electrically, if you will, insulated from the other signal, from the loop execution signal. So what will happen is 3 times this gating, 4 times, this gating torch will go off. for the first 3 times, the signal torch will be off. But then when we have executed the loop 3 times, the torch will come back on, basically indicating our signal is off. And what will happen is this last gate will pass through will cause the signal to pass through to the entity at the end, the loop exit. Okay, let's get to it. Let's actually do this so that we can see what's going on. And so would like to be able to see the torch here and still be able to see things though happening. Okay, so there are several things that we're looking for. First of all, there's a torch being placed here. Then what will happen is, and we can't see it, another torch will be placed way down there that will start the execution around here. Our first test 4 will turn this signal torch off, then it will turn off itself, causing a gating signal to be passed through. That will happen 3 times that this torch will go off. And then on the 4th time, the torch will come back on here for the signal, and the gate will pass through with the torch off up here, and will pass through the signal to the minecart. Thank you for staying with me through this whole explanation. There may be some people who will find it useful, though, to have gone through this whole thing, so please bear with us. And let's see, let's get as much out of the way so that we can see what we can see here. And now, I have to make sure that we can see things, so there we go. No, there we don't go. Okay, let's try again. I'm too far away. Too far away. Okay, well, we'll have to miss the torch behind us. But at least hopefully we can see other things. Okay, there's the first one. There's the second one. There's the third one. And finally the 4th one. And I hope you saw that the signal lit up, the signal line of redstone lit up, and caused the exit transport of me to occur, and I am now in the minecart. Okay, so let's get out of that without moving it. These things are pretty sensitive. And what we'll do is we'll go back and we will set the direction that we want to go to be in the positive Z direction this time. And let's see, maybe I can get a better viewpoint from up here. I have to be close enough to, I don't know that I'll be able to, unless I come at it from a different angle. Let's see, maybe. Okay, let's try it from here. Okay, there's our first gate. There's our second gate. There's our third gate. There's our 4th gate with the signal transmitted up to the exit, and here we are. So, come on. Okay, let's do one more time, and this time let's make it go in both the X and Z directions. And let's see, can we do it? Where can we do it from again? Over here. Okay. Get a nice view of things. Let's see if we can get the torch in this time. Okay. There we go. Did that go? Did not go. There's our first gate. Second gate, notice no signal. Third gate, no signal. And 4th gate with the signal. And we have now moved in also the X and Z directions, or in both the X and Z directions. Okay. Again, thank you for sticking with me. A lot of information there, some repetitive, but I think you got the idea. So thanks for watching. That's about it for now. And next time we will do a little bit more with naming our entry and exit points.